Hey PSY101 students, just wanted to create this video to go over the deep dive for lifespan development. So that was the assignment where I had you go and do this little puzzler here first. And just to refresh you again, so we start with two buckets. One is filled with 25 red trinkets, one is filled with 25 blue trinkets. We take 5 out of the red one and 5 out of the blue one, and we switch them. So then you end up with these two buckets. This one's got 20 red ones, 5 blue ones. This one's got 20 blue ones, 5 red ones. Then we take a sample of 5 out of each randomly. So we just reach into the bucket, grab 5 trinkets. We don't know what colors they are, and we switch them. And then the question is, which bin has more of the other color? So does the red one have more blue in it? Does the blue have more red? Do they have the same amount of the opposite? Or it's impossible to know because of chance. Now, in terms of the responses to this, we came in up, let's see, where was it? Let's do it from here. Okay, so if we go here, then we can see that the vast majority, 71%, chose that it's impossible to know because of chance, and that is a wrong answer. The correct answer, which 21% of you got, was that both bins have the same amount of the other color. And then 7% of you said the mostly blue bin has more red. Now, in terms of explaining the reasoning, the thing that we're interested in here is that when asked this kind of question, this is the most, by far always, the most common answer. And it's also the answer I would have given when I first did this. And it is wrong. And so partly when we're looking at is why do people explain it that way? And a lot of it really comes down to that it's chance. You can't really know what's going to be in that second set of 5 that you draw from each bucket. And so then that makes it hard to know how much is going to be in each bucket of the opposite color. So what I want to show you is why that's wrong, and then also talk about what it means for lifespan development, specifically around Piaget's theory of cognitive development. Okay, so to do that, I'm going to make it a little bit smaller, and we're going to just do this, and you can do this with yourself. You just take 9 pennies and 9 quarters. Okay, so same sort of setup. Here's the penny bucket, and here's the quarter bucket. What I'm going to do in this time is I'm going to take 3 out of each. So I'm just going to take those 3 out of the penny bucket, those 3 out of the quarter bucket, right? And we're going to switch them. All right. So that's that first step. And then from here, we would say, okay, now I'm going to randomly grab 3 out of the penny bucket. I'm going to randomly grab 3 out of the quarter bucket and switch them. And then the question would be, are there more quarters in the penny bucket or more pennies in the quarter bucket? Or will it be the same? Or you can't know because of chance. And again, what we know now is that the answer is it's going to be the same, that they'll have the same of the other coin in this case. So let me just demonstrate that to you. So I'm just going to take 3, and let's say, I'm not doing it so randomly, I'm just saying, okay, let's say I happen to grab 2 pennies and a quarter out of the penny bucket. But I grab, let's say, and let's just make it, let's say I happen to grab 3 pennies out of the quarter bucket. Okay, that'd be very rare, but it could happen. Okay, so now we switch them. Now notice that in the penny bucket there are 2 quarters. In the quarter bucket, whoops, there are 2 pennies. And so the number of the other coin in the bucket is exactly the same. Now, what's weird is I can keep doing this. I can take any 3 that I want. So I'm going to take the bottom 3 here from this one. Okay. And I'm going to take, I don't know, these 3 from this one. And we're going to switch them. Now notice that in the penny bucket, there are 4 quarters, and in the quarter bucket, there are 4 pennies. So partly the best way to explain this is that what's happening is conservation of number. So if you remember conservation of number, it was sort of the idea that if we said to a kid, say, okay, we've got 3 pennies here in this pile and 3 pennies in this pile, right? So we've got 2 sets of 3 pennies, and we can put them like this to each other. And we can ask a child, which of these sets has more? And they would even often count them. 1, 2, 3, 1, 2, 3. They have the same. And then we could say, okay, now what if I did this? Now we've got a set of pennies here and a set of pennies here. Which one has more? And a child who's in pre-operational thinking would say that this set here has more than the set up here. And they're going to say that because their schema for more isn't really well developed yet. That's why we call it pre-operational. If we think of operations as schema, schemas are just shortcuts. Through experience, we learn little ways to answer questions, quick ways that we can then just apply to future questions. And so more, in their case, is like a thing like bigger. And this one is sort of bigger, even though they know that there's 3 pennies there and 3 pennies there. At this point, the concept of more, because that's what I asked, which one has more, is being thrown off by this kind of not really fully formed schema of more. And so they will say this one has more. But you ask somebody who's in concrete operational, and they'll say, no, they're the same. There's still 3 here, there's still 3 there, because number was conserved. The number of pennies in each group didn't change, even though this one you spread them out. Or you can even shorten them. Okay, so you can take this one. This one does not now have less than this one. They both still have 3 because the number of pennies hasn't changed. So technically what's happening here is the same kind of thing. The number of pennies is staying the same. The number of quarters is staying the same. And often it's even really interesting to do it from the very beginning and to say, okay, even that first move shows you what's going on. I take 3 pennies from here, 3 quarters from here, right? Now notice, there are 9 total pennies. There are 9 total quarters. So if I move 3 pennies out of the penny bucket and I replace them with the ones from here, there's still going to be 9 total pennies because those 3 pennies are now over here, but there's going to be 6 left in the penny bucket. So what had to move? Well, it had to be quarters, but it doesn't really matter what moved. It's just that there's still 9 pennies. And if that means if there are 3 pennies in this bucket here, there can only be 6 quarters. And thus the other 3 quarters must be over here. So, okay, so that maybe, feels like a little bit different when it's just, again, switching the same group. So we'd switched 3 pennies with 3 quarters. But again, you can do it randomly. So now this time, again, we're doing 2 pennies and a quarter. And this time, let's do, again, same one here. Let's just do 2 pennies and a quarter from this one. But when we switch them, we now still have 3 quarters here, 3 pennies there. Same amount of the opposite. And it's because, again, there's still 9 total pennies. So if I had moved out, in this case, I don't think I moved, I moved 2 pennies and a quarter out, I think. I can't remember now what I just did. But it still really doesn't matter. It's sort of what's going to end up over here, and what isn't over here has to be over here. And so we aren't changing the number of pennies and quarters. It's always going to be 9 of each. It's just a matter of where they're split up. So the reason why I did this as part of a deep dive assignment for lifespan development is a little odd, because it really could easily just be one for cognition, because this is sort of a mind bender, right? And it's a little bit of a puzzler. But the reason why I put it in lifespan development is because people often get this one wrong. Okay, that fits cognition. But it's the why do we get it wrong actually can fit into lifespan development. Because, as we sort of point out, the reason why it will always be the same number of the other coin, 3 quarters here, 3 pennies here, is conservation of number. There's still 9 total pennies. Okay, so if this one has 9 in it and 3 of them are quarters, that means this one has to have 3 pennies in it. And if there are 3 pennies in it, the other ones have to be all quarters then. Because again, there's 9 quarters total. 3 of them just happen to be over here, so that means there's going to be 6 on this side. So the number hasn't changed. And so conservation of number is the answer to this, is how you figure out. That's the schema that we technically should apply. Why most people get it wrong, I would argue, is that they're not applying that schema. Now, so then people will ask, does that mean you are technically pre-operational thinking? And that's not what it means necessarily. Now, what I'm going to argue, because a pre-operational person, doesn't understand conservation of number. Well, I would argue you all understand conservation of number. You just didn't apply it. The 6 who got it right maybe did understand it and applied it. But the 70% who got it wrong, they got it wrong probably for 2 reasons. One is, I would argue, they're using a different schema. And in this case, it's the schema of chance, the schema of probability, which is actually a more advanced schema. It's a less concrete schema. Because the next stage after pre-operational is concrete operations. And then from concrete operations, we move to formal operations. And formal is really kind of short for abstract. We're doing more abstract, less tangible reasoning. And chance is kind of like that. Chance like what if. So it's all kind of in our head. And so what's happened is I think part of it is that we're trying to apply chance to this when, as it turns out, it doesn't really matter. It doesn't affect what ends up on either side. Because, yeah, I don't know what I'm going to get when I grab 3. That is true. That is chance. But ultimately, it's not going to change the number of total pennies and the total quarters in the whole set. So the other reason I would argue is that this... this task is actually probably more of a formal operations task. It is actually an abstract task, because when we go back to the beginning and we say, all right, once we've made our switch and we put our 3 pennies from the penny jar into the quarter jar and our 3 quarters from the quarter jar into the penny jar, you end up like this. And then we ask you the question, okay, at this point, imagine you sample 3 from the penny jar and 3 from the quarter jar just randomly and switch them. Which one will have more of the other, will have the same, or will be by chance? And at that point, you've got to be thinking in your head. And you're essentially using working memory, you're thinking abstractly, and that's where I think this is a more advanced task. And so I would argue in some ways, some people are getting it wrong, partly just because it's tough to think abstractly. And formal operations doesn't mean you're not in formal operations. It can, I suppose, but probably most people can do some abstract thinking. This just happens to be abstract enough that it's tough, but it also seems to blind us to the fact that the answer is a little simpler than it seems, because it is just simply conservation of number. So it is. I do this for this topic is just partly because it's a way for you to start to understand. When psychologists try to create these stages of cognitive development, it's not easy and they're not really clear. There's often a lot of things going on. And so when we're talking about schemas, there's often competing schemas that start to get in the way, that make it harder for us to be able to understand things and which schema do we apply and so on. And so it's hard to have these stage level things to know exactly where they are. And to just remember that there's lots of factors playing a role in terms of how we process information, and in this case, try to solve problems. All right, so hope that makes a little bit of sense to you, and just wanted to try to go over that in a video rather than writing it all out.